Hi there and welcome to Origin video number 6. So in the last video I showed how to create a test program flow and in this video I'm going to expand on that one and show how to create the actual tests that go with that flow. Okay, so before we get started writing some code, let's look at a little bit of background here. So if we go to the Origin guides, there's a section on the test program generator. Now there has been quite a bit of work lately, particularly on the test flow API that I showed the other day. And some of the documentation here might be a little bit out of date. If you do find any problems, please do comment here. We will happily update the documentation or help you out. But the introduction section here is definitely still correct. So this is the kind of overall structure of a test program generator in Origin. So Origin provides basically APIs to generate. So these are basically Ruby APIs to generate test program files. So for things like the J750 or Ultraflex, that means APIs to generate the flow sheet. This is what we used the other day. Then there's also APIs to generate the test instance sheet, the pattern set sheet, and so on. For the 93K, again, the same APIs exist. That shares a flow API with the Teradyne platforms as we saw the other day. But again, there's also 93K specific APIs to generate test suites and test methods and the other test collateral that goes along with that platform. Now what we did the other day was to create this flow. So this is the application domain now, what the application has to provide. The other day we created this flow. Then the next step now is what we need to do is to create what we call an interface. And that's really the translation layer that says for each one of the tests in the flow, this is how I want it to build on the target platform. So for example, if we're targeting the J750, then for each one of these tests I might want to build a test instance, I might want to build a pattern set to go with that, and so on. So this is what we're going to be building today. So the first step that we need to do is to go and build an interface. And if we look at the documentation here, basically an interface is just a regular Ruby class, and then we include this program generators module for Origin testers. This is what's going to give us access to the APIs to generate these test program resources. So we can simply copy that for now and go back to our application. Now you can put this anywhere. By convention this normally goes in the lib directory with all of the sort of standard Ruby classes. So we'll put it in lib-a-to-d-test and so let's create a folder called test program just to keep this separate from our model code. And then within that we'll create a file called interface. So if we open up that file here, we paste in the example. Now our module here, let me see, our module here is going to be a-to-d-test. The class can be whatever we like. Now we do have a choice here. By rights, because I've put this in a test program folder, that should normally indicate that a namespace exists. So I can do module test program here, or I could just leave it. Let's just put it in. So we'll put in a module here called test program just to keep everything clean. And this class is going to live within that sub namespace. Okay, now this is what we're going to work on today, this file here. So now we're going to open up the test program file from the last day, which is this one. So the idea here is that, as we saw the other day, this API of injecting tests here really takes care of all of the mechanics of how that actually gets built into a test program. And as we saw the other day, if we set up relationships between these tests, this will automatically create the required flow logic for the target pattern to make that happen. Now, some program generators take the approach that you just describe it in this sort of high level, you just describe the test in this high level way, and then it completely takes care of how it gets implemented on a given platform. Honestly, we don't really like that approach with Origin because there's always a subset of your tests where you're going to want to have to really define exactly how they run on a given platform. Really the instrumentation, differences between platforms are too great to fully abstract it. And sometimes you're going to want to have that control, that fine control of how a test gets implemented on a given platform, so that you can ultimately make use of the better instrumentation on that platform and make it as test time efficient as possible. However, for a lot of your other tests, maybe for 80% of your tests, you're not going to want to have anything special set up on that platform, and so it would be nice to be able to just write a single line like this and then get your test to fully generate. So the approach that we've taken here with Origin, with having the flow and the interface, really gives us the best of both worlds. It's going to give us that very fast turnaround of new tests in the future once we get the interface set up. But as we'll see in a minute, the interface also gives us that absolute low-level control of how a test is implemented on a given platform, so that for that subset of tests where we really need it, we do have the ultimate control. So no doubt that all sounds a little bit esoteric to start with, but let's get cracking with the demo here, and hopefully it will become clearer what I'm talking about as we proceed. So the first thing we want to do is tell this flow to use this interface. Now within this single application here, where we've got only one interface, that's not so important. But as you progress with Origin, you'll start to create flows like this in Origin plugins, and then you plug them all into an SOC application. And in that case, you might have many different flows and many different interfaces all coexisting within the one runtime environment. So it's a good practice to get into this now. So we'll just say that this flow should use this interface that we just created. So it's A to D test program interface, and that just links these two entities together. Now, the first thing we want to do here is to start creating some relationship between the flow and the interface. So right now we're calling test here, and that's an Origin level API that's going to just create the flow entry for this. But what we want to do instead is, let's say that this was a functional test here. So instead of calling test, we'll just indicate that this is a functional test here by creating a method called func, or we could do functional. It's really up to you. We'll just do func here because it's a bit easier to type. Now we go over to our interface now, and we actually create this method here that we just described. So this is where the naming is completely up to you. You could have called this functional or func. It's really just as long as these two things match up. So we'll call it func here. The argument for that is going to be a name, which is this, and then it's going to take a hash of options. And we may or may not take some options, so this just indicates that you can have 0 for this argument if you want. So that's that method created. Now to replicate our flow, in fact before we do anything here, actually let's just save this file off so we can track that it's still working. So before I proceed here, let's go to the console. Let's make sure our environment is set to the J750. We'll work with that to start with. So if we say Origin generate our program, what we're going to do is we're going to save this off so we can track what's happening here. So if we run it again, it's indicating that Origin is now tracking what we're generating, and that file is the same as it was before. So initially what I'm going to do is I'm going to change this to the functional method, and then over here we're just going to generate that test call here. So we'll just say call that test method, pass in the name and the options. So that's identical to what we did over here. Now in Ruby these brackets are optional, so we haven't included them here because I think it's just nicer in the flow not to have them. It's a bit easier to read, I think. But that we could have said here, test, open bracket, that, and then all the options. That's exactly the same as what we've done over here. Here within the method, I think it looks a bit better like this. It is really just personal preference. We could have done here that as well, and it would be the same thing. So now that we've done that, let's go and regenerate to make sure that this is all working properly. So that's generated exactly the same thing, and that's really indicating that we are making the call now from here over to here, and this is where we are injecting the test. So let's make all of these functional tests for now, and then we'll change some of them later on to something else. So what we'll do is we'll do a find and replace here for test, and replace that with func. So basically now all of our tests here are going to be going through our interface. We do have one in the A to D thing here as well, so we'll change that also to func. Now because this is a subflow here, I don't actually need to enter the interface because that will be inherited from the parent that called it, which is this flow here. So let's just double check that that's all working again. Looks good. So now we've basically got all of our tests going through this single point here. That allows us to initially do some very powerful things very quickly. So let's say, for example, we wanted to prefix all of our test names with A to D, because this is the A to D plugin here that we're working in. So what we could do is we can create a method here called let's say test name. And what we can do with that, so we'll just say name equals test name, pass in the name and the options, and we can now make some modifications to it here. So initially let's just say we'll turn back A to D and then the name that was passed in. So now if we go and look at our flow, we can see that it's made some changes there. I'll have a look at the diff. Okay, here we go. So we can see the difference is that all of these tests are now prefixed with the A to D sort of namespace. So that was very quick to do, and that was really because we've now got this nice architecture here where all of our tests are being generated from a single location here. Okay, so what next? So every time that we generate a functional test, let's say that we want to create a test instance and we want to create a pattern set entry. So let's say we want to create another method here called pattern name, where we will infer that from the test name. So let's just say initially that our pattern name is going to be the name of the test underscore pattern. Okay, so now what do we want to do here? So this is basically insert test into the flow, and here we want to create the test first of all. So if we want to create a test instance, we can look at the documentation for the J750 here. Now the Ultraflex page I think is not written yet, but basically it's essentially the same API as the J750, very very similar. So let's just show me here how I create a functional test instances. So I can say this one as this shortcut, I can say test instances dot functional and then the name. Okay, so let's say our instance is going to be test instances dot functional, and then we pass in name. And then instead of inserting that test into the flow, we actually can insert that instance instead. Okay, so let's go and try that now in the console. Okay, so this has made a couple of changes here. So there's a change to my flow. Yep, so that's just because I forgot to save it last time. It's just still that A to D namespace addition. But now it's created this test instances file for us. If we have a look at that. Okay, so here's our test instance sheet here with an entry for all of our tests in our flow. Now, if you've got any experience with IGXL, hopefully you're already starting to appreciate the time that this can save. If you're doing all this manually in IGXL, then every time you add a test, you have to go to the flow sheet, you enter it there, you then go to your instance sheet, you then add it there. And you do that for every single one of these. But here I've pretty much instantly generated my test instances without having to do really much work at all. And of course, the benefit now is that because I've now created this interface method, if I create a new test here, then it's a functional test like all the rest. Then at that point I've just added that one line and now I'm done. The test instance will automatically create and follow the same rules as all the other functional tests. Now, we are going to likely want to decorate this instance a little bit. The way that we do that is usually with decorator methods. So let's say we'll create a method called apply, let's say apply levels, and that's going to take a test as the argument. So before going further here, I'm just going to save this stuff before I forget, so we can see what changes. So basically, if you look at IGXL, each of the columns in the spreadsheet has got a name. So for each of those column names, this test instance will have an associated method, which is going to be the lowercase underscored version of that name. So let's say, for example, I want to set the DC and AC selectors. So here's an example actually in the documentation. So it's instance.ac category AC selector. So we'll just actually copy that there. In fact, I'll just copy all of this. And in fact, let's change this to, let's call it something like apply conditions, because we're going to be setting the timing as well and the pin levels. So basically, so I'll just change this to instance. So we're going to set the AC category to spec, that to default, and let's just say we'll do the same with the DC category and the DC selector. The time set is going to be a sheet called time, and that's going to be the level sheet that we use. Obviously just change the name of that as appropriate for what you want to use. Okay, so I'll just say, I'll just call that here apply conditions to the instance, pass in the options, and we'll show why we're doing that in a minute. Okay, so we're now going to create the kind of base instance here. By default, we're using this, so here we're using this sort of functional template that Teradyne provides. So by default this will have exactly the same default options as it would if you were to create it natively in IGXL. So I've got that basic instance there, we've applied the name. Now we're going to hand it over to this method here where we're going to decorate it with some application specific information, and then we're going to get it back again, and then we are then going to insert it into the flow. So let's go and see what happens now. So we ran that there. Now we've got a change here which I wasn't expecting. Oh yes, of course, so I added test D, so we can see that appears here in the flow. And then the change to the instances. Okay, so here I've got my my test D is in here again, and then here's all the updates from applying the spec selectors and the timing sheet and the level sheet that we want to use. So that's all good. Save this off. Now right now this is quite static here. Basically every single test instance will have this same setup here. Now what if we wanted to, for example, run some tests at min VDD and some at max VDD? So let's say that this test day is actually going to be a max VDD test. So the way they would indicate that would be like that. Now the idea here is that from this flow sheet, anything that is a property of the test you would really define here. You don't really define it in the interface. But the idea here is that within the flow sheet you're trying to be completely test platform agnostic. So we don't want to start saying things like AC selector equals or DC selector equals, because the naming of that is a very Teradyne specific concept. Rather we want to indicate here things like, the abstract properties like what's the VDD, what are the test limits, what's the frequency, that kind of thing. That would all go in here, but try and define it on a fairly generic term. And then as we'll see later on, that then makes it easier then to retarget this flow to something like the 93K or some other test platform. Okay, so I've got this VDD max here, now how would we implement that? So also another goal of this is to try and write as little as possible. So we can see already that we haven't said VDD in any of these other tests, so we can create a convention for ourselves that if we don't mention VDD, then it will be the nominal or default condition. But if we do mention the VDD, then that's a specific override. So here we're going to run this test VDD max. So how do we do that? So we did pass in these options all the way down to this apply condition. So we can simply say here, if options VDD, else we'll just do that, and then we can just say if options VDD equals max. How do I want to implement this? So let's just say okay, just implement it like this. So if it's max, then we'll say that the DC selector, let's just say it's going to be max, and then if it's min, it'll be min. Let's also implement nom, in which case it will just be the default. And then else, it's nice to give ourselves an error message, so rather than letting this fail silently. So obviously what we're dealing with here is very production critical. We really don't want the case where somebody does a typo here, you know, like that, as I'm prone to do at times. We don't want the case where somebody does a typo here and they end up getting that test running at nominal instead of max, right? That's a quality issue. So anytime you are doing things like this, try and create a fail condition if you don't recognise the option. So we'll say unknown VDD selector, and then we can just pass it out there. I'll show you in a minute this actually in action. Okay, so that's that handled. So we can go and generate a program. So now the only change is to the instance sheet. Okay, and here we go, and we can see that the change that's made is that it's changed the selector of this guy to maximum instead of default, which is exactly what we want. And now of course that means that we've now added that capability to any test. So any other test that we want to run at max VDD, it's just a sort of min VDD, we can just say, you know, VDD as min, and that's us done. That's that change made. Now let's also just quickly show what if we did do a typo here. So if we did that and then we run it, then this is the kind of error we'll get, unknown VDD selector, mint. And then this is the stat trace. So you should start to read this as you're using Origin. So this is telling us basically the line that it failed on. So our test program interface file, line 28. So if we go there, you can see that that was the line that actually generated the error. So we want to just go back up the stack trace until we get to something that means. So then it went to interface line 10, which was this guy. So we're still not really seeing the error. Then it actually went from sort 1 program flow file line 25. So we come down here now, say, here we go, this is the error here. So you should definitely start to use that in your day-to-day work. I'll just generate this again and save it because I did add that min VDD test. We don't need to look at that, but I will save it off. Okay, so that's essentially how the instance generation works. You can apply whatever else that you need to in here. Basically every property, every column in that IGXL instance sheet is a method like this, so we can set it to anything that you want in here, depending on what you want your test to do. We'd want to probably also add a pattern sheet reference. So does the documentation give an example of that? Search for pattern set. So let's just see if I've got any pat set maybe. Okay, so here's how we create a pattern entry here. Okay, so let's just copy that example. So create the test, and then we want to create a pattern set entry. So for an example here, We're creating a pat set here, and then the pattern. So let's just say the pat set name is going to be basically the test name underscore pat set, and then the pattern is going to be, so we're going to kind of the path here, so let's say ours would be patterns A to D, and then we did create a method earlier on called pattern name, so we'll just say it's going to be pattern name options dot pat. Okay, that looks good. Now this is going to return the pat set, I think, so we can say pat equals that, and then we can link the two of these things together, so we can say instance dot pattern equals that pat set. Okay, so let's go and try that. So we've got our changes to our instances, let's have a look at that. Okay, so the change here is that, yeah, basically all of our patterns. So I think that's not quite right, so that's basically injected the pat set line in there. So I think actually the way that this is intended to work is that basically we make the name, pat set name equals that, and then we'll say that's pat set name and pat set name. Okay, so that should work now. Okay, so so that looks better. So each of our instances now has got a reference to a pat set, and then it's also generated this pat set sheet now. So we'll have a look at that. So here's our pat set sheet here. We've got each of our patterns. We've got the link to the path of that pattern on disk when we come to running our program. So again, that's now something that we get for free every time we add a new test to the flow. We now get the pattern set done for free as well. Now for the J750, we've got APIs to generate the test flow entry, the pat set sheet, and the test instance. That's basically because these are the places where we spend most of our time, and by us I mean the people who use Origin today. So things like the DC spec sheet, the AC spec sheet, the timing sheet, we don't generate those through Origin today. Instead, what we do by that is we make them by hand in IGXL, and then if we need to make them dynamic, we compile them through the Origin compiler. So that's if you look at one of the other videos on how the compiler works. You basically just put your DC spec sheet through that compiler, and then you can customize it to the current device if you need to. For the UltraFlex, there's a much fuller API available. Our digital networking team in NXP has done a lot of effort there to add APIs to basically define all of these sheets. So pin sheet, timing sheet, all of the level sheets. There's APIs for all of them, Ruby APIs. So they have a very, very complex Origin model which contains thousands of pins and things like that. And then they can use that model in here to generate a complete complex pin sheet, for example. But hopefully that gives you enough of an idea how this works. If we wanted to now, let's say some of these tests were actually parametric tests, so let's say this was actually a parametric test here, we'd change the name of this. So let's say it's my parametric test. Let's say our low limit is going to be, I don't know, 10 millivolts, and then we're going to have a high limit of 20 millivolts. Okay, so that's generally how you would do something like a parametric test. Of course, that means now we have to create a parametric method here to handle it. So run that again. So now we'll get some changes to our instance sheet. So we can see that the existing test here is now changed from a functional to a PinPMU template, and the pat set's there, and is the limit. Yep, so it looks like the limit was actually pulled out as well, so that's our test limits there. Okay, so that looks good. So now we can generate PinPMU parametric tests as well. And I think I'll probably leave it at that for the J750 side of the demo. You would really just extend these principles now to do other types of instance setups. Now, I'm not going to cover it in this video, but in a future video I will show how you create an API to talk to maybe custom test instance setups that you have. So here we're just using the kind of stock Teradyne ones, but you can also use this with custom test instances, so I'll show how to do that probably in the next video. So let's say now that our company buys a new fleet of testers or something, and we want to utilise them to run this same test program. Now what we've done here with this architecture is we've kind of separated the flow description, the complete flow description, including bin numbers, limits, VDD levels, all that, everything really is in here and is platform agnostic. And in a real life case this might be very much bigger than this, this might be hundreds or even thousands of lines long. But then we've got our instance here, our interface rather, which is very, very specific to the platform that we're currently running on. So let's say we want to run on the 93K instead. So how do we do that? So what we need to do is we have to make basically no changes, or we don't want to make any changes here. If we've written our flow in a good platform agnostic way, as I've shown here in the demo, then we shouldn't have to change this at all. And really the act of implementing support for a new platform now is really just enhancing this interface to deal with that platform. So let's start off by going through our functional handler here and to basically gate off anything which we consider to be J750 specific. So the name initially that's going to be common. Then the instance here is of course Teradyne specific. So here we can say if the current tester is a J750, then I'm going to do this, else I'm going to do something else. Apply conditions, that's probably going to be generic. And then the pattern set name, that's probably going to be quite Teradyne specific as well. So we'll do that. Okay, so for the 93K, we want to create what they call a test method instead of a test instance. They're essentially the same thing, it's just different terminology between the two platforms. Now, unfortunately, the 93K is something that we've added support for quite recently, and we haven't had time yet to update the documentation. We've just got a placeholder here for the 93K. Now this does come from Origin testers. Now what you can do if you do see missing documentation quite often is you can go to the release notes for the given platform. So quite often you will see things like this to show new APIs before we get around to actually adding them to the documentation. So there may be some stuff in here that's shows some of the 93K APIs. So here's one here actually. So here's how we create a test suite for a test method. So actually I'll just copy that, it's quite nice. So that's a good tip, anytime that you need to get some documentation, you can look at that first of all to see if you get it from there. Let me just copy this before I lose it. Now the other thing that you can do is you can look at the API. The API is documentation or method on all the methods and all the classes that's been extracted from the Ruby code itself. Now again, it will take a while before you kind of find your way around this stuff. The kind of key things that would be of interest here for the 93K side would be the AC test method library. So this shows that if you're familiar with 93K, this is the test method library that comes from Advantest, basically the default library. So I've implemented a couple of methods here to do a functional test. I'll use that in a minute. There's also a frequency one here. This method library probably does supports other setups as well. We just haven't added them here yet. Again, if you need to do that, please just raise a ticket or get in touch and we'll add that, or even better, we might show you how to add it yourself. And then you can start contributing those additional setups. So that's the AC test method library. I'll link to these in the video notes. And then the DC test method library is another one that's been implemented. So here you can see that we've set up a lot of more. So these we'll probably use one of these in a minute to do the parametric implementation on the 93K. So go back to our interface. So what we do here is we create what we call a test suite first of all. On the 93K, so we're just passing in the name and the options. Now that's going to be, yeah, okay, so we already applied the test name, so that's fine, so we'll do that there. And then we'll call this instance because it will align with our other code. Now the test method that I want to use here is one from the AC test method library, so it was AC TML, is it AC TML dot functional. And I think that's probably it. So let's just generate that and see what happens, see what that does. So save this off. So why did I save that there? So as I've shown during this demo and other demos, this ability to track diffs is very useful when you're making changes, so you can see the effect of what you're doing. But the other thing it's very useful for is regression testing. So I want to make sure that while I'm adding this V93K, I'm not changing the output for the J750. So I've just saved that off there, and now if I generate the program for the J750 again, that's good, I've not made any differences, so I know that my J750 program is still going to work properly. Now for this generation I'm going to change the environment to the 93K and now run it. So I got an error, undefined method functional for AC test method library. So I'll go back to this API here and see what that was called. So it's called functional underscore test. So let's go and change that. Okay. We'll generate that. So undefined method AC category for test suite. Okay, so that's happened because we are applying this conditions here like this. So this is again, yeah, this is very Teradata specific, so we'll say ftester.j750 and then do this. Otherwise handle it for the 93K down here. So I'll come back to that in due course. So now we get undefined local variable method test instances for that. So this is the parametric test, so we haven't updated the parametric one yet either. So I guess we'll just do the same thing here. If it's the J750 and if it's the J750. Okay. Okay, so I'm getting some kind of error here, which is definitely not obvious what it is. This is really pointing towards a weakness in Origin at this point. It's kind of hit some piece of internal code where it hasn't really handled the error very well. It's not giving us a nice message here. So definitely, if you see this thing in the wild, please do raise tickets, and then we'll try and fix that for the future. But this thing will happen to you from time to time, and it's happened to me here. So let's look at how we might resolve this. So by default, the stack trace information that you get when you run here in the console only shows up to the level of your application, and it's not showing me any application information here. So that kind of indicates that it's failed somewhere in the kind of bowels of Origin, and it's not bubbling that error up very nicely. So how would we debug that? One thing we can do initially is we can say we can run with a dash verbose option here. And then when it fails with that, it will dump the complete stack trace here, which will go into, so here we can see it's failing within the Origin Testers plugin. The problem here it's now became obvious to me. It might not be obvious to you, and I think in that case, this is a case where please just come to the forum and let us know that you've had this problem. We'll try and help you out. But more than that, that then lets us know that we've got a weakness here in the platform where we need to give better error feedback. So the problem here is actually in our parametric method here. We haven't created the instance for the 93k. So we're passing in this this blank thing here. We're passing in nil basically for the instance, and it's causing it to fail. So let's just, for now, we'll just copy this down here just to get us going, just to create something. We'll come back in a minute and change that to a more proper test method. So if we go now and run again, now it's generating properly. We can go and have a look at what we get here. Now with SmartTest, everything tends to be on the one sheet here, the one file. So this is basically our test methods and our test suites and our test flow all combined. So we can see here that we've got, as we come down, here's the test method limits. So actually here's the limits for our parametric test that did get picked up and injected there. Here's the test methods here, so we can see that all of them are using this functional test pre-built class right now. And then here's our test suite definitions here. This is really, so these two things combined are kind of the equivalent of the test instance within IGXL. So the test suite is where you add things like the level and the timing information, and then the test method is where you add basically the test specific arguments, roughly equivalent I would say to the interpost function arguments in IGXL. Here's all our test suites here, and then down the bottom here we've got our flow itself. So again, we're getting the same benefit as we're getting the Teradyne there. Now we just add one line to the flow if we're adding a new test, and we get all those components built for us. So that looks good as an initial step. We'll save that off. Let's try and make it a little bit better. So one thing here, we haven't added the pattern. Now it doesn't really have the concept of pattern sets the way that it does on Teradyne. So I think all we really need to do here is we can just say, so let's pull this pattern name bit out here. So pull that outside of the tester specific clause. And then I think here we just want to say basically instance.pattern equals the pattern name. Okay, so that should now attach the pattern to the tester and to the test method. And I think that should probably has pretty much done. Oh, the one thing we haven't done here is the conditions. So the V93K, things like the levels and the timing, these are a concern of the test suite. Now this generation API here is quite a nice feature set up where if we link a test suite with a test method together like this, so basically this is the test method that belongs to that test suite, we get back this single entity which will basically handle any methods that apply to the test suite or which apply to the test method. So it means you can treat it like a single entity in the same way as you can on the Teradyne. And that just makes it a little bit easier to create an interface that deals with both. You don't have to be thinking really, oh, is this a test suite method or is this a test method? When you're dealing with 93K, you can just basically think of it in similar terms. You've got this one test instance object, and then we decorate that as required. So how do we? What are the methods that we can use here? So again, if we go back to the API, because we are lacking documentation right now on the 93K, look at the let's see the test suite, and I will link to this again in the show notes so that you can find it. But basically this shows here, these are the attributes that all the test suites have. So we can see that it's timing equation, timing spec, timing set. These are the things that we want to set here. Level equation, level spec, level set. These are kind of the equivalents of the AC and DC specs on Teradyne. There is some aliases set down here as well, so you can say instance.timeset equals, and that's equivalent to that, level set and so on. So let's just pick a couple of these For now we won't do them all, just to give you an idea. So these are the three that we're going to use. Okay, now on ATK these tend to be numeric type of things, so let's just say this is level equation 14, spec number 1, spec number 1. Now again, we'd add similar logic in here that if we wanted VDD, we would use a different VDD max, we'd use a different spec and so on, but I don't think you're going to gain anything by me showing that right now. It's just exactly the same as we did above. Okay, so if we go and try that now in our generator, we are getting a difference here, so we can go and look at that. Okay, so here we can see that the test suite setup is now starting to populate with these. That's basically the DC spec levels that I've set here. Okay, so we can save this off. Now the parametric test, it would honestly just be exactly the same principle as I've showed before. I may not actually go much further with that right now, but basically it would be that we pick one of these DC specs, one of these DC test method libraries. So let's see. So I guess the general PNV will be the kind of rough equivalent of what we're doing on the Teradyne. So we just say basically this should be the DC library. General PMU. Okay, if we go and try that. Okay, so we can see that this test method has changed from a functional to this PMU setup here. There's a lot of things here that have been entered by default. Again, this will match what you would get if you were to create a new one of those in SmartTest natively. But obviously, you can just use these method names here to override them from your interface. Or again, if you look at this API here, you can see that basically these are all the methods. This is the default value if we don't apply anything. So you would just say instance.pinList equals something, instance.forceValue equals 2 volts or whatever you wanted to do as appropriate. Okay, so hopefully that gives you a good introduction to the test program generator and give you an idea of how to use it. It is a bit of a learning curve initially to get started with it. It is definitely a new mindset you will need to adopt. Really, people who use this generator, really our goal is to use the actual ATE native environment as little as possible. Now we obviously, when we're doing the very first a flagship device or something, we write the program quite heavily in the native API and then we backport it to Origin. But then for derivative products, really our goal for them is for them to come out as never to have to touch a real test program, and then it will all just work. And a lot of times it does work like that, sometimes it doesn't, and we need to get involved with the SmartTest or IGXL natively again. But overall, anyone who uses this, I think far prefers it to dealing with the sort of native vendor APIs. You can be much more productive and you can generate things really quickly once you've got a good interface set up. Now, one of the things that we hope to see in the future is that in fact this functional method here and this parametric method here, for example, these could absolutely be taken out of here and wrapped up into an Origin plugin. And so then you would just say in here, include some plugin, and you would get these two methods for free. And what that means is then at that point, then you don't have to even implement the interface. You can just call the functional method and the parametric method and so on directly from the flow here. So even though there is quite a bit of work right now to create the interface, everything that you're doing here can be reused within your own projects. Or if it's a generic thing that you think could benefit the community as large, please do think about releasing it. and then everyone can start to use those setups and can start to contribute back bug fixes to them, and so on. And one last thing before I go is that you may have noticed every time I've been generating here, it said that the list has been written here, the pattern list. So this is basically the list of patterns that have been referenced in that program. So another nice thing about generating in this way is that if you maintain a program by hand, you tend to build up a lot of cruft over time. So tests that test instance setups or test method setups, which are no longer actually referenced in the flow. So every time you're generating the program here, you're always getting only what the current flow needs, and then it's outputting here as an offshoot of that the patterns that you actually need to create that program. So now basically you can point this list towards your pattern generator. So you can say origin generate that list file. It would work in this case because my application doesn't have these patterns implemented, but in the real application then that would generate all the patterns to go with your program. Okay, so there will definitely be some more videos on the program generator, but hopefully that's a good introduction. The next one I think will be to show how to use custom test methods and custom test instances within your program. Okay, so thanks a lot for now. Bye bye.